So now we are going to prove next proposition, proposition 5.2.8, and this says that delta lambda perp is equal to kernel uh, T star lambda conjugate, and because delta lambda is a closed subspace by proposition 5.25, delta lambda not equal to x implies kernel T star lambda conjugate not equal to 0. Moreover, by corollary 3.1.8, we have delta lambda equal to kernel T lambda star, kernel T star lambda conjugate per, and kernel T lambda equal to delta star lambda conjugate perp. Moreover, kernel T lambda perp is equal to delta star lambda conjugate. There are a lot of notations here. You have to keep in mind each and every notation. Kernel T lambda, we have to prove this one. Okay. So first, what was our assumption? In first part, we have assumed delta star lambda conjugate is equal to image of T star lambda conjugate. Okay. So what we have delta star lambda conjugate is equal to image of T star lambda conjugate. We have this. And here what we have to prove, delta lambda perp is equal to kernel of T star lambda conjugate. Okay. Also we have to prove delta kernel delta lambda is equal to kernel T star lambda conjugate perp. We have this one, and finally we have kernel T lambda equal to this one, and we have to prove this one also. Okay. So before that we have to remember uh, some previous things, and we have this result. What is, if L is a subspace of X, then L perp is equal to set of all F belongs to X star such that F of L equal to 0. This is a definition of a L perp. F belongs to X star, linear functional such that F of L equal to 0. So this is a collection of linear function. Similarly, if F is a subset of X star, okay, here F is a subset of a dual space, then F lower perp is equal to intersection of F belongs to F such that kernel F. Okay, uh, this is actually intersection of all intersection of all kernel of linear functions in F. Okay, F lower perp. And also we have this result. L is a closed subspace, then L perp lower perp is equal to L. And this is our corollary 3.1.8. L perp lower perp is equal to L. Okay. And we have in fourth chapter, we have one result, one exercise problem, page 74. If A belongs to L of xy, then image of A perp is equal to kernel A star. Similarly, kernel A equal to image of A star perp. I think this is already done by some seminar. Okay. So image of A perp is equal to kernel A star. We have this result. And kernel A equal to image of A star perp. You have to keep in this mind this result. Okay. Image of A perp equal to kernel A star. A belongs to LXY. Once again, image of A perp equal to kernel A star. Second one, kernel A equal to image of A star lower perp. Okay. So here we are taking y equal to x and a equal to t lambda. So apply this result for t lambda. For a we are replacing as t lambda. Okay. So what we get? Image of t lambda perp equal to kernel t lambda star. Image of t lambda perp is equal to kernel t lambda star. Now what is t lambda star? Here actually we have okay kernel t lambda kernel t lambda star. Now what is kernel t lambda star? T lambda star. What is t lambda? T lambda is t minus lambda I star, and this is equal to t star minus lambda I star, and this is equal to t, but we have assumed in the first part we have already denoted, we will write t lambda I star as lambda conjugate I. So this you can write as t star minus lambda conjugate I, and this is equal to t star lambda conjugate. Therefore t lambda whole star is equal to t star lambda conjugate. Therefore, kernel T lambda star is equal to kernel T star lambda conjugate. So, what we get? Kernel. So, image of T lambda perp is equal to, what is image of T lambda? Image of T lambda is delta lambda perp, which is equal to kernel T star lambda conjugate. Okay. This is our first result. Now apply this to next result. Apply this result. Okay. So kernel t lambda equal to, we replace a by t lambda. Kernel t lambda equal to image of t lambda star perp, lower perp. So here kernel t lambda equal to image of t lambda whole star perp, but image of t lambda star is t star lambda conjugate perp. But kernel t lambda, what is kernel t lambda? Kernel t lambda is, what is kernel t lambda? Delta t, delta lambda. Delta lambda is kernel t lambda equal to image of, sorry, kernel t lambda equal delta, this is delta t star, stay here we have this result. Image t star lambda conjugate is delta star lambda conjugate. So here we have kernel t lambda equal to, kernel t lambda equal to delta star lambda conjugate and perp. I think it is clear. Image of t star. Okay, so kernel t lambda equal to delta star lambda conjugate perp. Okay. Now what we have to prove? I think there is no need to write this portion. Okay. Now what we have to prove? We have to prove kernel t lambda perp is equal to delta star lambda conjugate. Listen carefully. So what we have to, what is kernel t lambda? Kernel t lambda is set of for x such that t minus lambda I x equal to 0. Okay, and this perp, what is this perp? Some L perp is set of for f belongs to x star such that f of L equal to 0. So what is kernel T lambda perp is set of for f belongs to x star such that f of kernel T lambda equal to 0. And we have to prove that's equal to delta star lambda conjugate. So some we are assuming some f belongs to delta star lambda conjugate. So what is this is equal to image of t star lambda conjugate. Delta star lambda conjugate is image of t star lambda conjugate. So f belongs to image of t star lambda conjugate. So this f is in image means there exists a h belongs to x star such that f is equal to t star lambda conjugate of h. For any x belongs to kernel T lambda, f of uh, and f belongs to f belongs to delta star lambda conjugate. But we have f of x equal to t star lambda conjugate h of x. Okay, t star lambda conjugate h of x, and this is equal to by the definition of star, we have a star a star phi of x equal to phi of ax. That means here h of t lambda of x, but x belongs to kernel t lambda, therefore t lambda x equal to 0, therefore h of 0 which is equal to 0. Therefore for any x belongs to t lambda, f of x equal to 0. That means f of kernel t lambda equal to 0. Okay, that means f belongs to kernel t lambda perp. F of x equal to 0 for every x belongs to kernel t lambda. That means f belongs to kernel t lambda perp. Therefore, delta star lambda conjugate is contained in kernel t lambda perp. Delta star lambda conjugate is contained in kernel t lambda perp. Clear? Now we have to prove the reverse inclusion. Let f belongs to kernel T lambda perp, which is equal to set of all g belongs to x star such that g of kernel T lambda equal to 0. Okay, so f of kernel T lambda equal to 0. Therefore, f of x equal to 0 for every x belongs to kernel T lambda. Now we have to prove f belongs to delta star lambda conjugate, and that's equal to image of t star lambda conjugate. For proving this, we have to prove there exists a h belongs to x star such that f is equal to t star lambda conjugate of h, because we have to prove f belongs to image of t star lambda conjugate. For this, we have to prove there exists a h belongs to x star such that f is equal to this one. So for proving this, let y belongs to image of t lambda. That is y belongs to delta lambda. What is the meaning of that? There exists a x belongs to x such that y equal to t lambda x. Okay. So now we are defining a map uh, h naught from image of t lambda to c such that h naught of an element y belongs to h naught of y equal to f of x. Okay, h naught of y equal to f of x. Now we have to prove h naught is well defined. Let x1 belongs to x such that y equal to, we have to prove there may exist some x1 which is satisfying this condition. So we have to check whether this function is well defined, because there may exist another function here. Sorry, there may exist some other point x1 for which f of x1 is same as this value. Okay, so let x1 belongs to xb such that y equal to t lambda x1. Okay, here we have y equal to t lambda x Suppose there exists a x1 such that y equal to t lambda of x1, and we have to check whether h naught of y equal to f of x equal to f of x1. Okay, so x1 and t lambda, and t lambda x1 means y equal to t lambda x1. Also we have y equal to t lambda x. So t lambda x minus t lambda x1 equal to 0. T lambda of x minus x1 equal to 0. That means x minus x1 belongs to kernel t lambda. That means f of x minus x1, f of x minus x1 is equal to 0 because f belongs to kernel t lambda. Per, therefore f of x minus x1 is equal to 0. That means f of x1 equal to f of x. Therefore this map h naught is well defined. Now linearity of f, we get h naught is linear functional on image t lambda. And we have one claim for any norm of x is less than or equal to norm of c plus 1 into norm of y. We have assumed the claim is alpha y equal to, just to recall our proposition to 5.2.5, alpha y equal to infimum of norm of z such that z belongs to ey. Okay, in that case alpha y is less than or equal to c into norm of y. Okay, so here we are assuming norm of x is less than or equal to c plus 1 of norm of y. So h naught of y is equal to mod f of x, which is less than or equal to norm of f into norm of x, which is less than or equal to norm of f into c plus 1 of y, and we get this is a bounded linear operator, and we can extend this by Hand-Banach extension theorem. There exists a h satisfying all the conditions. Okay, therefore there exists an extension of h to x star. Okay, image of t lambda 2, we have this is a extension to x, and then that h belongs to x star. Now for any x belongs to x, t star lambda conjugate h of x equal to, by definition, h of t lambda x, and this is equal to t lambda x, where is t lambda x belongs to image t lambda. This extension is same for h naught and h, because h naught, h is the extension of h naught. So where is h? H is actually on image of t lambda. So for any element in image of t lambda, h naught is same as h. Therefore h naught of t lambda x and h naught of t lambda of x is f of x. Thus we get f is equal to t lambda t star lambda conjugate h. That means f is in image of t star lambda conjugate. Therefore f is belongs to therefore f is image of t star lambda conjugate implies already by our assumption image of, okay, um, t star lambda conjugate is equal to kernel t lambda per, therefore f belongs to f belongs to sorry, and from this f belongs to image of t star lambda conjugate, but we have assumed let f belongs to, yeah, where is our f, we have assumed f belongs to kernel t lambda perp, and we get f belongs to image of t star lambda conjugate, that's equal to delta star lambda conjugate. From this is a this inequality also holds. That implies we get kernel t lambda perp is equal to delta star lambda conjugate. Okay.